Welcome students. We are back with another lesson. In this lesson, we'll discuss spherical lens. So, what are spherical lens? Spherical lens are any transparent glass surface that causes the light to converge or diverge. So, spherical lens, this is one spherical lens, this is another spherical lens. So, what your spherical lens does? It converges the light. Can you see the light is being converged after refraction? So it converges the light or it diverges the light, as you can see in the second figure. Fine. Next we'll discuss types of spherical lens. What are the types of spherical lens? Your spherical lens can be categorized into concave lens and your convex lens. Your concave lens, okay, it is bent inwards. It is bent inwards. Whereas your convex lens are bulged outwards at the center of the lens. Can you see? So this is your concave lens, which is bent inwards at the center, and this is your convex lens, which is bent outwards at the center. Convex lens can be further categorized or further classified into three types of convex lens. This one is your biconvex. When the lens is curved on both parts, as in this case, this is your biconcave lens. Okay, at surface 1 and 2, the surface 1 is also a convex lens, the surface 2 is also a convex surface. Surface 1 convex. So when the lens have convex surface on both sides, then it is known as biconvex lens. When the lens has convex surface on only one part, this part, let us say at your first part, at this part it is curved, whereas on the other side it is plane. Fine. Or let us say on surface 1 it is plane, on a surface 2 it is convex. We will have a plano-convex lens. As you can see, this is your plano-convex lens, plane at one surface and convex in another. The next one is your concave convex. You have a convex surface at your first surface. Can you see? This is your convex. Sorry, this is your concave. Okay, this is your concave. It is bent inwards at the center. Can you see? So what kind of surface is this one at surface 1? It is concave. Fine. At surface 2, it acts as a convex. Can you see? At the center it is bent outwards. So at surface 2, what kind of surface you have? Kind of lens which has a concave and a convex surface at the two respective surface, then such kind of lens will be known as your concave convex lens. Similarly, your concave lens can be further divided into three types of concave lens. So let us consider your first one, this one. Okay, now on the first side, okay, this side, what kind of surface you have? Look, it is bent inwards at the middle of the lens. If it is bent inwards, then what kind of surface is this one? This is your concave lens. Clear? What about on your second side? On this side, it is also bent inwards at the when there is a concave surface on both the sides of a lens, then in that case such kind of lens will be your biconcave lens. Now consider your second. This is your first side. Okay, now on the first side it is a plane surface. Okay, it is a plane surface. Okay, this side is a plane. What about your second side? This side, this surface. Can you see this surface is bent inwards at the center? And if it is bent inwards at the center, then what kind of surface is this one? This is a concave surface. A lens has a plane surface on one side and a concave surface on the other side, then such kind of lens will be known as your plano-concave lens. Yeah. Let's come to our third one. When your first surface, this one, in this case, can you see the surface is bent outwards at the center? If it bends outward at the center, then what kind of surface is this one? Convex. Now consider your second surface, this surface. Fine. In this case, can you see it is bent inwards? Then what kind of surface? This is a spherical lens has convex surface on one side and a concave surface on the other, then such kind of lens will be known as your convex concave lens. Clear? Now let's discuss some common terms related to the spherical lens. Okay. Now, what kind of lens is this one? This is your convex lens. Now, can you see the center? The center of the convex lens is known as your optical center. Fine. Can you see this line? This line is known as your principal axis. Fine. Now, if this is a convex lens and this surface is also convex, can you see this surface? This are your convex. Now, can you see the center of this surface? This point. This point is known as the pole of this surface, of your first surface. So this is written as P1. Fine. This is your surface. The center of this surface is known as your pole. Fine. Similarly, the center of this curved surface, this point is also the pole and it is represented by P2. So this is P1, this is P2, and the center of the lens is known as your optical center. Fine. Similarly, if you are considering this spherical surface. Okay, then let us draw this imaginary sphere. Now the center of this sphere is known as your center of curvature C1. Fine. Similarly, if you are considering this surface, then let us consider this sphere. Then the center of this sphere is known as your center of curvature and it is represented by C2. Fine. Now the radius of this sphere, this distance, is R2, which is your radius of curvature. Similarly, the radius of this spherical surface R1, which is also known as radius of curvature, is represented by R1. Fine. Concave lens. The center of this concave lens is known as optical center, this point O. The center of this surface is known as pole, represented by P1. Similarly, the center of this surface is known as pole P2, represented by P2. For the first surface, if you are considering this spherical surface, okay, then this we have to consider this sphere. Then this point is the center of curvature and it is represented by C1, and this distance is known as your radius of curvature, represented by R1. So next, if you are considering this spherical surface, then we have to consider this spherical. Fine. You have to consider this sphere. Now if it's this sphere, then the center of this sphere is known as your center of curvature and it is represented by C2, and this distance is represented by R2 and it is known as your radius of curvature. Fine. Optical center. We have discussed about poles. What are poles? And we have discussed about center of curvature and its radius of curvature. Fine. And the C1 and C2, you don't have to get confused. Okay, you can consider vice versa also. Okay, you can consider this one C1 and you can consider this one as C2. Similarly, yeah, you can consider this one as C2 and you can consider this one as C1. So this is not that much important. Okay, you can consider any spherical surface or name them, fine. But if you name one point as C1, then the other center of curvature will be denoted as C2. Okay, so whenever you write 2 points, okay, you have to represent one with 1 and the other surface definitions as 2. Okay, so that you don't get confused. Fine. But apart from this one, this point can be your C2. If this is C2, then the center of curvature here, this point should be written as C1. Fine. And you can write vice versa. But both of them should not have the same notation. Clear? The same convex surface or your convex lens. Fine. Next, we'll discuss sign convention. Now let us discuss first for your convex lens. Okay, now remember, according to sign convention, the light is always incident in which direction? It always moves from left to right. Clear? So any direction along the incident light will be taken as positive and any direction opposite to incident light will be taken as negative. Start for your convex lens. Okay. So if you are measuring this distance, okay, if you are measuring this distance, okay, so this distance will be positive or negative? It will be positive. Fine. Similarly, if you are considering any distance in this direction, clear? Suppose I'm considering OF1, then OF1 will be positive or negative? OF1 will be negative. Clear? And OF2 will be positive. Clear? So all the distances which are measured along positive and all the distances measured opposite to the direction of incident light will be taken as negative. Next, the next point is that for both concave and your convex lens, the distances should be measured starting from the optical center. The distance for concave lens also, from where we have to start measuring, we have to start measuring from O. So if I'm measuring this distance, I'll write this one as O F1. Okay, similarly in this case, if I'm measuring this distance, I'll write O F2. Fine. Next, all the distances which are measured in the upward direction. All the distances which are measured in the upward direction will be positive for your convex lens. All the distances which are measured in the upwards direction for your concave lens will be positive. Fine. Similarly, all the distances which are measured in the downward direction for the convex lens will be negative. In this case also, for the concave lens, all the distances which are measured in the downward direction will be negative. Fine. So these are your sign convention. So what was the first point? The first point was the light should always travel from left to right. Fine. Left to right. Second point was all the distances should be measured from the optical center O. The third point was the distances measured along the direction of incident light will be taken as positive, and the distances which are measured in the direction opposite to incident light will be taken as negative. Fine. Next, all the distances which are measured in the upward direction will be taken as positive. All the distances which are measured in the downward direction will be taken as negative. So if this is your convex lens, okay, this is your convex lens, then this point, the distance between the optical center and the focus, okay, suppose the light is incident, okay, the light is coming and after refraction it travels, suppose the light is coming, after refraction it travels through this point F. So what is this point? This point is known as your focus, and the distance between the optical center and the focus is known as your focal length F. Fine. So in this case, your focal length for your convex lens in this case will be positive or negative? This will be positive. Why is this positive? Because it is measured in the direction of the incident light. Fine. Now let us consider for your concave. In case of your concave lens, the light comes and it gets refracted and it bends away from the surface. Clear? Can you see? So that the light bends away from this point. Can you see? The light diverges from this point. So this point is known as your focus for your concave lens. Fine. So the distance between the optical center and the focus, this distance is known as your focal length of the concave lens. Clear? So the focal length of the concave lens will be positive or negative? It will be negative. Why is it negative? Because it is measured in the direction. It will be always negative. Clear? So in case of your convex lens, this was your light. Your this distance focal length is positive or negative? It is always positive. Whereas in case of your concave lens, in this case, this distance is known as your focal length, and it will be positive or negative? It will be negative. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So thank you.